So for this lesson, we're going to be learning how to find the area of a bounded region enclosed by the parabola of this equation and a straight line of this equation. So when we're doing this problem, we're just going to be using the definition of the area of an enclosed, the definition of an area of a region between two curves. And when we do this, first thing you want to do is kind of sketch it out, like Miss Jensen always says. So you have a graph somewhat like this, and you know that at x equals 0, y is equal to 6, and it's an upward sloping graph. So it's going to look something like this. And you know that this is an x squared, so it's a parabola, and it's going to be downwards like this. And for this one, you can kind of find the points of intersection a little ahead of time to help you graph this by setting it equal to each other. So you would do 10 plus 3x minus x squared is equal to 6x plus 6. And then when you move the variables over to the same side, you get x squared plus 3x minus 4 is equal to 0, which when you factor it out, you get x plus 4 and x minus 1. So x is equal to 1 and negative 4. So now that you have this, you know, because it's going to be a negative, you know there's some type of intersection here and at like negative 4. So you can kind of just draw a sketch like this. And you know that you're going to be finding the curve. I mean, this is not going to be accurate, but you at least know which one's going to be the bottom and top function, right? Because if it's anything less, it wouldn't make any sense. So obviously the top function has to be the parabola. Now that you know that, you can set up your equation, and you know that the definition of this area of two curves is the integral from a to b, which we found 1 and negative 4, of top function minus bottom of dx. And dx is, of course, the representative rectangle we're supposed to have drawn. Sorry about that. It's dx right here. And you know that by looking at this representative rectangle that the top function is going to be the parabola. So you just plug in your numbers. You're going to get negative 4 and 1. And you have 10 plus 3x minus x squared minus 6x plus 6 dx. And when you solve this out, you get the antiderivative of course, negative 4 to 1 of 4 minus 3x minus x squared dx. Then from here you can take the antiderivative, which is 4x minus 3x squared over 2 minus x cubed over 3. And do this. Yeah. Now, you can plug in your variables, of course, or your numbers, should I say. It's always b minus a, so 4 minus 3 halves minus 1/3 subtracted by a values, which is negative 16 minus 24, if I'm right. Should be right. So yeah, 4 times 4 is 16. 16 divided by 2 is 8. 8 times 3 is 24. So yeah. And then this is going to be 64/3. Okay, now when you simplify this, of course, the first one you're going to be left with is, this is the same thing as 1.5. So 1.5, 4 minus 1.5 is 2.5. So 5/3. 5/3, right? I mean 5/2. Sorry about that. Yeah. And then minus 1/3. And okay, from here, you simplify, you common denominator. So it's going to be times 3, so 15, 6 minus 2, 6. You get 13, 6 for this side. And then now working this side across, of course, kind of want to separate it. You know that this is going to be equal to 40. So negative 40, 40 minus 64/3. Okay. And you multiply this by 1/3, so it's 120 pretty much over 3 minus 64 over 3. It's negative here too. So this all becomes a positive, and you add them together and you get 184 over 3. Multiply that by 2. So you can get its common denominator, and then you add it up. So when you add this up, 184. Alright, just for time's sake, I'm going to multiply it on my calculator. And the answer, answer should be 381 over 6.